This video is the third in a series which explains how Accanto Stratoss achieves 100% service lifecycle automation for next-generation services. In this edition, we will demonstrate how Accanto Stratoss platform, incorporating AI-powered diagnostics, enables a significantly higher degree of operational automation. In order to explain where this part fits, let's recap on what we're trying to achieve overall. The amount of manual effort in operating complex network services increases exponentially with the use of traditional OSS systems. Automation of the operational lifecycle, not just the onboarding and design, has become essential to make the model commercially viable. The greater the operational automation, the more efficiencies. Once live, the operational maintenance of a service is proportionally the largest percentage of the cost and effort. It is here where Stratoss outperforms traditional OSS, reducing manual effort 30 times more than with traditional systems. There are three elements required to achieve 100% operational automation. First, intent-driven orchestration fully automates the operational lifecycle of a service without the requirement of manually scripting program code. This offers a cost reduction not only in manual labor, but also in the level of skill required. Second, integrated DevOps-enabled service behavior testing reduces the number of errors in services before they go into production. Fewer errors means less manual effort to diagnose and resolve issues. Stratoss fully automates the spinning up of test or pre-production environments, instantiating services and necessary monitoring and test resources before running automated tests that run through the full service lifecycle. Third, AI-powered diagnostics. On achieving 80% operational automation through the use of intent-driven orchestration and integrated service behavior testing, production errors may still occur. Artificial intelligence can then be used to automatically diagnose and resolve issues that would normally require human effort. So let's start. Before the service goes into production, it needs to be designed. Stratoss includes a designer with which you can easily design the service. In this case, you can see the global voice service consisting of multiple VNFs, such as the London and the New York gateways, as well as a core. You can also define the relationships and dependencies between the components. Notice that we did not have to program a single lifecycle script for install, start, stop, heal, scale, upgrade, etc. Once you're happy, the service can be instantiated. This is where the intent-driven orchestration kicks in. The Stratoss intent engine is generating and automatically executing the intent to bring the service from its current state to its intended state, in this case active. It is doing this by running each VNF through their lifecycle in the right order and all fully automated. Once completed, the ready for service test is started. Stratoss is first installing traffic generators to simulate traffic, monitoring components such as probes, and then runs through a full set of service tests. In this case, you can see calls for the voice service flowing through the system in ONAS. All these metrics, such as the successful calls seen here, are stored in Kafka. Now what we will do is to manually inject an error. In this case, we will force one of the gateways to be misconfigured so it does not get an equal load of the traffic like the others, even though the service is running properly, and no calls get dropped. This anomaly is then detected by an analytic system that kicks off a full service diagnostics. The service behavior tool automatically installs additional traffic generator and monitoring probes into the service and will start diagnosing each of the locations of the service. It will run through a full set of test cases and will report all of the metrics into Kafka. Once these metrics are there, an AI tool, in this case IBM's Watson, compares the results from the metrics and sees that the off behavior is happening in the London location and requests a more targeted diagnostics to that location. Again, Stratoss automatically runs through a series of tests and you will notice that one of these tests fail. This failure then triggers Watson to kick off a heal request to Stratoss, and the intent engine carries out the requests and heals the broken gateway and reestablishes any relationships to get the full service back into shape. As a conclusion, in order to create commercially viable NFV solutions, the traditional OSS systems do not provide enough automation. In order to significantly lower the operational costs for NFV services, a much higher degree of automation is required. Three elements are needed for this. Intent-based orchestration that enforces brutal automation of the entire lifecycle of these services to remove manual effort in designing and especially in operating the services. an inbuilt service behavior-driven test to fully automate service testing and reduce the amount of errors of services that go into production. And thirdly, when things do go wrong, AI can be used to trigger diagnostics and automatically resolve issues. These three elements combined in Stratoss enable a significant operational automation and have been shown to deliver over 30 times more operational efficiency than traditional OSS systems.